environmental impacts of net zero and carbon negative policies. We have sent Senator Hicks to the Forest Health briefing because unfortunately the two meetings overlapped and they are very intrinsically related. So we sent him as our representative there. It's an annual meeting we have every year about the health of our forests. And welcome, Senator Cole. Yes, thanks for joining us. It is no secret that many legislators disagree with the governor on his stance and policies regarding CO2. However, this meeting is strictly about CO2 and related policy issues, and in no way intended to be personal in any way toward the governor. But we do have a definite difference of opinion on policy issues regarding CO2, and Wyoming citizens deserve a public hearing on the issue in which the voices from the experts that have been largely silenced are given center stage. So thank you for being here. It is hard to believe that there are two sides regarding to even be taken regarding the facts and scientific information concerning CO2. However, if proponents of a different viewpoint wish to express that, they are free to have a hearing of their own. On this committee, we understand the importance of CO2 for agricultural production, in farming and ranching, producing food and raising livestock, and we understand the importance of CO2 in our environment, wildlife, and forest health. We understand the value of CO2 in our public lands, and we understand the value of the Wyoming energy industry. We understand that CO2 is the basic building block of all life on Earth, and we must continue to educate ourselves and our neighbors to its benefits. This is why we welcome our distinguished guests here today. From the CO2 Coalition, Dr. William Happer, Gregory Wrightstone, and Byron Soepyan. Did I say that right?
It's actually pronounced Soepyan.
Soepyan, thank you.
Thank you.
And our own Kevin Kilty from Laramie, Wyoming. Thank you for being here, gentlemen. And with that, I will turn it over to you for your presentation. We look forward to hearing from you and taking copious notes.
Thank you, Senator Steinmetz, very much. I'm Gregory Wrightstone. I'm the Executive Director of the CO2 Coalition. I'm a geologist and also an expert reviewer for the Intergovernmental Panel on Climate Change. I first was involved in the climate change issue as a geologist. I knew that some of what we were being told about climate change was just wrong. I suspected other things. And that led me to a deep dive into the facts about climate change, which led me to the writing of my first book. And now with my publication just last week of my second book. We're gonna go through what's typically a 45-minute presentation here in about 12 minutes. If we could put that up, please. And so I've carved out what I think some of the most salient issues that you may not hear. And I've also incorporated Wyoming-specific data. If you haven't grabbed one, there is a copy of our new publication, just published last week, Wyoming and Climate Change. CO2 should be celebrated, not captured. And that's available also on our website by searching for Wyoming. We'll get started here.
And Mr. Wrightstone, I think we have copies in the back. If anyone here would like, they've been so generous as to bring many copies for distribution here and provide several other resources. While you're getting that put up, I'm going to just show everyone. They've sent us a very convenient warming, which Gregory wrote.
If we could get that up as as a view.
Yeah, and we'll go through these at the end when we can actually see them on screen. but they've provided a lot of good information for us.
If we could see that as a screen, as a PowerPoint show, please. Okay. So a lot of this, we'll go through here. Much of this was derived from my new book, A Very Convenient Warming, much of the charts that came out of that. So let's start with who is the CO2 Coalition. It was founded in 2015. One of the founders is sitting next to me, Dr. William Happer. We're more than 150 of the top scientists in the world with a skeptical viewpoint on the relationship, and we're opposed to the notion of a human-driven climate crisis. For example, here are just four of the top scientists, part of our membership. Top left is Dr. Patrick Moore. Notably, he was a co-founder of Greenpeace. He rode those pontoon boats out against the fishing fleets against the whales. He found that they were wrong. He now sits on our board. He believes as we do. Top right is Dr. John Clauser, current Nobel laureate in physics. Notably, he was honored at the White House last spring. After his presentation, he shook Joe Biden's hand and told him, "Sir, the science you're using for energy and climate is just wrong." Joe got angry and told him, "You're just spouting right-wing science." It's hard to call John Clauser a science denier. To my left, sitting here, is Dr. Will Happer. He'll explain his credentials in a bit, and also Dr. Roy Spencer, the University of Alabama at Huntsville. We're going to go through, we'll take a look first at carbon dioxide, some of the big picture items through time. We'll look at temperature, what it's doing in the recent and long-term picture. And specifically, what you'll really be interested in is our Wyoming-specific temperature data. And then we'll take a look at the benefits of modest warming and more CO2. So let's take a look at the modern, this chart of CO2 goes back to 1750. It's the CO2 in the atmosphere. And you can see here now, just bear in mind in my presentation, if you see a blue line, it is carbon dioxide. You can see back then it was about 280 parts per million at the beginning of the Industrial Revolution. Today it's a little over 420. So we've seen a 50% increase in carbon dioxide. Notably, CO2 started increasing in the post-World War II era in the mid-20th century. And that's, if we're going to see carbon dioxide-driven warming, it'll be in that period of the last 70 years. But it's important to put this as a geologist in the long-term geologic context. So let's take a look back through geologic time, as I'm wont to do. We take a look and find out that, remember, we're at 420 parts per million today. The average throughout geologic history was 2,600 parts per million, 6.5 times what we are today. And you'll also note that the red dashed line at the bottom, the blue dashes are where we are today. And you'll know that today's CO2 levels are at near historic low levels based on compared to Earth's history. And notably, the red line is what I call the line of death. And that's the line below which plant life can't survive. We nearly crossed that threshold in the near-term geologic history. If we ever crossed that, that would be a true climate catastrophe. We wouldn't be here, plants wouldn't be here. And we're actually still very close to that line of death. So let's take a look at temperature globally and in Wyoming. This is the Hadcroot 5 data set that goes back to 1850. And you can see we've been in a warming trend. If we look at the long-term temperature history, we find that the warming trend that we're in actually started more than 300 years ago. It predated the increases of CO2 by 250 years. So we'll find that first 250 years. Okay, well, let's take a look here at Wyoming and temperature. And this is the average annual temperature in Wyoming. This data set and the following Wyoming data set comes from the United States Historic Climate Network data from NOAA, National Oceanographic and Atmospheric Administration. This data begins in 1895 and goes up to 2023. And you'll see the average temperature here in Wyoming has increased a little over 1 degree Fahrenheit in that time. Nothing alarming, but we'll see. Let's see what makes this up. We're being told that high temperatures are increasing, heat waves are increasing, people are dying because of increased heat. Okay, well, this is what NOAA data tells us. The maximum average daily temperature on an average has been in decline for more than 90 years. It peaked in the 1930s, and it's been in decline. It's gone up and down, but the general trend is not increasing as you will hear in the media. It's been decreasing. This is confirmed by looking at the percent of days with temperatures above 100 degrees Fahrenheit. Again, this is Wyoming data. It's been in a slight decline, but there's certainly been no increase in the percent of days with temperatures over 100 degrees. Again, this flies in the, you're going to hear me say this a lot. It's completely opposite of what you're being told. And this, again, is Wyoming-specific data. There is no heat-related climate crisis in Wyoming. And the key, what is driving then temperature increase? We say it increased by 1.2 degrees, the average. Well, let's take a look at the coldest nighttime temperatures. Interestingly, and again, I'm comparing this to CO2, interesting, the coldest nighttime temperatures have increased significantly. And that's what's driving the overall increase in temperature in Wyoming. And that's a good thing. What that does is we'll learn a little bit. It gets really cold here in Wyoming. I don't have to tell you that. And a slight increase in the coldest nighttime temperatures would be welcome, and particularly welcome by the farmers. What does that mean? It means an increase in growing season. Killing frosts end earlier in the spring, arrive later in fall. That's a good thing. That's a really good thing for agriculture. So let's take a look at CO2 versus temperature. We're being told that CO2 is driving temperature. That's the main driver of temperature. Remember, I said that CO2 started increasing in the mid-20th century. Again, the blue line is CO2. Just as we started adding significant carbon dioxide to the atmosphere, the Earth went into a 33-year decline in temperature. I graduated college in the mid-70s. At that time, we were being told of a looming ice age. We had just seen 33 years of declining temperatures, and who knew when it would end? It did end, and it started warming. But again, just as we started adding CO2 to the atmosphere, we had 33 years of cooling. This is the longest temperature record available from thermometers, Central England temperature record. It goes back to the year 1659. You can't really see it here, but the warming actually, the little bit of warming started in the year 1695. So we've had more than 300 years of warming, and I've superimposed on that carbon dioxide. I'll let you conclude what you will on the relationship. Taking a little bit longer term, CO2 versus temperature, we take a look back for 1,000 years. We look back to what was called the medieval warm period. Again, the Vikings were growing barley on Greenland. We know from historical records that it was much warmer at that time. And then it was followed by the death-dealing horrific cold of what was called the Little Ice Age. We know the Little Ice Age from historical records was very cold. For example, just south of me where we work in Arlington, Martha Washington loved ice in her drinks in the summer. George Washington at that time could go down to the Potomac and cut the blocks of ice, thick blocks of ice, and bring it up to his ice house. That hasn't happened. The Potomac hasn't frozen over in 20 years. Historical records like that I like to use to document warming and cooling. Again, looking at 8,000 years of data, we see that, again, CO2 in blue, red is temperature. We have a trend of increasing CO2 and decrease of temperature, completely opposite of what we're being told. And one thing I love to talk about is the close relationship between the rise and fall of temperature and the rise and fall of civilizations. They're closely linked, and we find that each of the previous warm periods, going back to the first great civilizations, the Hittites, the Babylonians, the Assyrians during what was called the Bronze Age, the Minoan warm period. Each of these warm periods were warmer than we are today. Civilization flourished, food was bountiful, great empires arose. And each instance, when it started getting cold, it led to crop failure, famine, pestilence, and mass depopulation. Cold, in each case, was related to horrific consequences. Warmth was related to bountiful life, great empires, and benefits to humanity. We'll take a look at extreme weather and natural disasters. This is data gathered by the UN. The increase you see from 1970 to 2000 was building out of the stations reporting the data. Since 2000, they've built all their stations. We've seen a 10% decline in reported natural disasters. Once again, completely opposite of what you're being told. A 10% decline in natural disasters. We see that global deaths from natural disasters have declined more than 90% since 1900. There's a lot of things that go into it. Most importantly, it's better reporting and forecasting. They report there's a Category 5 hurricane came descending on Houston, get out of the way. They didn't have that in 1920. So that's part of it. But again, it's opposite of what we're being told. We're being told of mass death that's increasing because of increasing natural disasters. It's just not so. We're also being told the drought will increase. This is a recent study, global study from using 2 data sets, and they report a significant global decline in drought going back over the last 70 years. One of the stark contrasts we see here is just misreporting and fabrication of data. This is area burned of the lower 48 in the United States. This is from the 4th National Climate Assessment. The data starts in 1983, and my internal alarms went off when I saw this. They didn't tell what the source was. I found the source and exposed them for what they were. They started their data in 1983, but had data going back to 1926. And you'll see that is the area burned increasing? Slightly, yes, but they declined to show that the burned area in the lower 48 today is 20% of what it was 80 and 90 years ago. And that's confirmed by the Copernicus satellite data of global area burned over the last 20 years. Again, that confirms the globally burned area is declining. I could show you chart after chart confirming this. I will say that the increase that we see in the United States of area burned is related to mismanagement of our forests, particularly in federally held areas, complete mismanagement. I won't go into detail there. In the United States, again, we see that the percentage of days above 100 degrees peaked in the 1930s and has been in a decline. Again, this comes from the NOAA data, USHCN data. When I say global warming saves lives, people's heads explode. The truth is, this is the largest study of its kind. Dr. Antonio Gasparini looked at 74 million temperature-related deaths and found that 20 times as many people die from cold as from heat. Another recent study said it was 15 times. All right, if it's 15 or 20 times, still, a warming trend would save millions of cold-related deaths. I'll say it once again, completely opposite of what you're being told. Vegetation, one of the greatest things and the benefits we're seeing of the combination of modest warming and more CO2 is what we call a global greening. Vegetation is expanding across every niche from the near polar regions to the equator. This is a NASA satellite image. The green is expanding vegetation. The little bit of brown you see there is where vegetation is decreasing. And that's a combination of warming. We see that tree lines moving further to the north in the northern hemisphere and higher altitudes climbing up. Food production is expanding greatly. These are the top 8 crops in the world by tonnage produced. Each of these crops is breaking records year after year after year. And the experts that have looked at this say it's related primarily to 3 things. One is warming temperatures. Again, we talked about a longer growing season. That helps expand food production. Primarily, though, it's the increase of carbon dioxide in the atmosphere that's fueling plant growth. It's called the CO2 fertilization effect, and it's something that we're seeing from the coldest countries to the warmest countries like India are experiencing this great boon in agriculture. And because of that, we're able to feed a growing population. This chart is from the UN. It shows that global food production is greatly exceeding global population growth. So if you're being told there are too many people on this planet, we can't feed them, the facts contradict this. We talked too about the value of warming, extending growing seasons. In the continental United States, the growing season has lengthened more than 2 weeks since 1900. We've also told it that, again, the droughts are increasing. But we look at it, again, this is data related, global precipitation from satellite data. We see the precipitation is increasing modestly globally. And if we take a look in our book, we look at the Wyoming precipitation data. This shows about the same thing. We see great variations between snowfall and precipitation from year to year, but there's no trend in increase or decrease. This is not Wyoming related, but we're being told that sea level rise will be swamping islands in the Pacific, in the Indian and Caribbean areas. Well, this is the island nation chain of the Maldives that UN lists as the most at-risk nation. It's barely above sea level. 15,000 years, this nation, these islands were also just barely above sea level. And I'm going to tell you something you've never heard. Over the last 15,000 years, sea level has risen 400 feet. Why are these islands not under 400 feet of water? It's because of a geologic process known as accretion. And during storm events, the nearshore sediments wash up on the island, and the island slowly grows along with sea level. Now, they're going to tell you that these islands will be underwater by 2050. Using the current sea level rise rates, we're going to have 2 inches of sea level rise by 2050. So what they're telling you is the last 400 feet of sea level rise didn't put them underwater. But look out, that next 2 inches, they're going to be underwater. And these are the falsehoods that they're telling you. And they go undisputed because the science has been silenced. So in summary, there is no climate crisis in Wyoming. There is no climate crisis globally. And we should celebrate CO2, not capture it. Thank you.
All right, committee, thank you very much. All right, committee, would you like to ask some questions? Senator Larson.
Madam Chairman, thank you. I just have one question. Early on, I heard about the line of death. What would that number be?
150 parts per million.
Okay.
We got to 182 during the depths of the last glacial advance. So we're
Wow.
within a whisker of
Wow.
that.
Thank you.
Senator French.
Thank you, Madam Chairman. Sir, what do you think is driving their narrative that the CO2 is bad and it's going to warm, and after the 1.5 Celsius increase, we're all going to be in big trouble? What's driving that false narrative?
I'm asked that a lot. And I can't look inside men's and women's souls to see what motivate them. And so as a scientist, my job is to say, this is what they're telling you. But let me just address this 1.5 degree narrative. It's already warmed 1.2 degrees. So of that 1.5, it's warmed 1.2. So what they're telling you is beware of 0.3 of a degree centigrade of warming, which equates to 0.5 degree Fahrenheit. It's just changed 0.5 degree Fahrenheit in this room recently. You've never noticed it. It wouldn't trigger the thermostats on or off. It changes more than 0.5 degree Fahrenheit between 11 a.m. and noon on almost every single day. And if you're that worried about 0.5 degree Fahrenheit of warming, you can move 19 miles farther north and your average temperature will drop 0.5 degree Fahrenheit. That's what they're warning us about. And when put in that context, it looks ludicrous.
I have a question about net zero and carbon negatives and the line of death. Can you kind of collate that for us? I mean, where will this policy take us if we say all of our efforts in this area pan out and we reach net zero or carbon negative? What does that mean and collate that with the line
Well,
of death?
If we put that together, reduction of CO2 with also what's being proposed, not by Governor Gordon, but by the other climate zealots around the world, reducing or eliminating nitrogen fertilizer. They're talking about geoengineering and blocking. Dr. Happer's written a recent publication. He predicts millions of lives lost, and he's better suited than I am to deal with this. But we're actually CO2 impoverished right now. Our plants are not thriving and growing to their full potential now. And so more CO2, beneficial CO2 in greenhouses is usually around 1,000 or 1,200, which is three times what it is. It would probably be better higher, but there becomes an economic limit for greenhouses on how much they can put in. So again, we're CO2 impoverished, and the plants, we would have reduced plant growth and agriculture production.
Thank you. Senator Ide, did you have a question?
Thank you, Madam Chair. Mr. Wrightstone, thanks for that presentation. That was excellent. I'm not going to let you off the hook as easy as Senator French did on his question. That was he asked a lot of the same questions that I was wondering too. And I think everybody has sort of formed their opinion already of why, they're creating this hoax of this emergency. And it appears obvious to, any thinking person and common sense that there's something nefarious here. And you've been in the trenches on this. What do you see out there? I mean, why can you confirm, in particular, my beliefs that this is just nothing more than, trying to beat down human flourishing and enslave the people?
Well, I'm tempted to just give my honest opinion, and I can tell you what the results of this is control of every aspect of our lives. You know that, from what we can drive, how we heat our homes, how much water comes out of your shower in the morning. You're asking me why are they doing it, and I do lots of interviews, and I'm asked this question almost every time, and I turn it around and ask the interviewer, what do you think? Because you are as qualified as I am to say why they're doing it. I can tell you I can tell you this is what they're doing. Each one of you there is just as qualified to say why they're doing it. And I've heard it's control, it's destruction of the Western economies, of capitalism. We know from a lot of the scientists it's funding. If they don't go along with this climate narrative, they lose their funding. It could be all of these things. Some people truly believe it. There are people that truly believe this. We don't. We need to provide the information, and it frustrates us having these qualified scientists that are silenced.
Go ahead, follow up.
Thank you, Madam Chairman. Just a quick, I had another question. We see a lot of stuff floating around in legislation on, carbon sequestration, which is storing it, versus carbon for enhanced oil recovery. And, I guess it's proven that CO2 injection into old oil formations enhances oil recovery substantially. I used to be in the oil patch, and I know Representative Alamans here, he works in that field, and he can attest to that. I guess my question is, the storage part of it, to me, seems like a complete waste of time and resources to do something like that.
Yeah, our third speaker here, Dr. Soepyan, will address that, but I'll address the storage aspect when it comes to oil, the miscibility of CO2 in oil, and to use it as to drive more oil out. That's not sequestering, because number one, it's going to end up it's going to produce more oil, which then we burn to produce more CO2, which we say is a good thing because we love a big carbon footprint. And we think it's beneficial. But also, a lot of that CO2 ends up going out, you pump it in the disposal wells, it ends up moving along with the oil and is miscible in the oil, and a lot of it ends up going out to the production wells. So that, if you're looking for sequestration and a way to keep it in the ground permanently, that ain't it. All right.
All right. Are there any further questions? Okay, we might have some for you at the end, some more. We'll go on. Who would like to be next?
I think I'm scheduled to be next, and so
That's
I
wonderful.
don't
Welcome.
know whether I've got a briefing on
Go
here.
down, push down.
Push down.
All right.
So
We'll
help me.
find it. And when you find it, or while Greg finds it, would you tell us?
Uh-huh.
Yeah.
Okay, that's great.
Yeah. Would you tell us your name and that for the record?
My name is William Happer. I'm a retired professor of physics at Princeton University. And I've been working in this area of climate and the atmosphere for a long time. Much of my early work was heavily classified, and I'll tell you a little bit about that. But would like to say that Greg gave a very good talk. I agree with everything he said. And I might add on the question of why people believe that, I think one of the biggest problems is that for many people, it's almost a religion. You know, if you look around, you need something bigger than yourself, you know, to make your life worthwhile. And what's better than saving the planet? And so the problem is the planet doesn't need saving. And but nevertheless, the people need something, you know, to feel good about. So I think that's a non-negligible part of this problem. Of course, there are other motives too. People make a lot of money by taking advantage of this hysteria. And as Greg said, people like control, and this is a great way to get control. But you shouldn't neglect the sincere people who've been misled and think they really are saving the world. So let me move on, though, to say a few words about CO2 itself. My field is radiation transfer, and I'm best noted I was elected to the Academy of Sciences because I invented an important tool, you know, for defense and later for astronomy that involves the atmosphere and radiative transfer. And this was work that I was doing back in 1982, so that's more than 40 years ago. And I was co-author of one of the first books about the long-term impacts of increasing atmospheric carbon dioxide. And this was work we were doing for the Department of Defense. Even back in 1982, they wanted to know what would happen from more CO2. This book, you can still find it. It was not particularly alarming. We overestimated the effects of CO2, but not by very much. And but the reason I didn't fuss with that too much, I knew it was an overestimate. It was essentially groupthink, because I was working at that same time on something I thought was more important, and that's shown on this next slide. And this is the sodium guide star. So this was the very first year of the Strategic Defense Initiative, you know, Star Wars. And we were challenged as a scientific community to think of anything that we could that might stop missile attacks, you know, from the Russians. And one of the things that was obvious was maybe you can burn them out of the sky with high-power lasers. And I remember that Senator Malcolm Wallop, maybe some of you remember him, was a big fan of that. He wanted to put them in space, but that's very, very expensive and difficult. And so an alternative would be to put them on the ground. And the reason Senator Wallop didn't like that was because he knew a little bit of physics. And the physics is if you take a megawatt laser and you aim it at an incoming attacker from the ground, by the time the laser gets to the attacker, it's broken up into hundreds of little beams, and none of the little beams has enough power to cause any damage. You don't have that problem in space because the laser doesn't have to go through the atmosphere. And so this is something that's caused by the little patches of warm and cool air in the atmosphere. Even if it's a completely blue sky, it looks perfectly transparent. It's really not for lasers. So it was known at that time that you could solve this problem if you could measure the distorting effects of the atmosphere, and astronomers knew how to do that. So at night, if you have a really bright star, you can measure the incoming radiation, and what happens is the radiation is supposed to be a plane wave, nice and flat, coming from a star, but as it goes through the atmosphere, it gets bent up, and twisted. And so as it's coming down toward your telescope or going toward the target, if you're going the other way, because of this twist, it won't focus properly. So you don't get a nice point, you get all sorts of points, hundreds of them. And so the astronomers knew you could fix it by distorting the astronomical mirror. So they had what they called rubber mirrors. And so you would squeeze the mirror in just such a way that when this distorted wave would hit the mirror, it would bounce and it'd come up perfectly flat, and then you could focus it. And so that was called adaptive optics. But to make adaptive optics work, you had to be able to measure the distortions of the atmosphere. And there were only 4 or 5 stars at night that were bright enough to do this. And so unless the Russians were accommodating enough to attack us from the distance, directions of those 4 or 5 stars, there was no way we could overcome this distortion. And so we had a very secret meeting in 1982, and there were a number of generals in from the Air Force from Washington. It was out in California, and I was in the meeting. It was a room of not much bigger than this. It was actually smaller than this. And I said, well, I know how to make artificial stars, because there's a layer of sodium atoms over the Earth at about 100 kilometers, and all you have to do is make a laser, pay to make a laser that will excite the sodium atoms, and then you can make a yellow star wherever you like, including the direction of the target you're trying to kill. And so most of the people at the meeting had never heard of this. By chance, I knew about it. And to the Air Force's credit, they went back to Washington and they did due diligence. This was all very secret. And they got back to me later in the summer and said, we're going to try it out. We've let a contract to build a laser, and we're building a secret observatory in New Mexico, south of Albuquerque. And I was getting quite nervous now, because this was, many millions of dollars on my suggestion, and which had never been tested. But to my relief, they tested it, and it worked the first time. So I got a lot of credit then in the classified world in Washington. Most people didn't hear about it for 15 years when it was finally declassified. But I will say, if you go to any big telescope today around the world, they all have these yellow guide stars, and so that's my guide star there. So anyway, I tell you this because you should listen to what I say about radiation transfer, because this is my field and I know how it works. And so I'm going to tell you a very short physics course here on radiation transfer and how it's affected by carbon dioxide. And the takeaway message is, it's no wonder that Greg can't find any effect of carbon dioxide, because it's a very puny greenhouse gas. It really doesn't make much difference. And I'll explain why now. So the way greenhouse gases work, and clouds are very much like greenhouse gases, is that they hinder the thermal radiation that cools the Earth to space. The only way we can cool ourselves from the heating from the sun is to radiate thermal radiation off to space. And if you get clouds in the way, or if you get CO2 in the way, that hinders the cooling of the Earth. So that's the fundamentals of the greenhouse effect. It's not terribly sophisticated. And it's much like the way you would insulate your house. So here's infrared radiation coming out of a house, and it's an infrared camera. And you can see that where it's red, there's a lot of radiation coming out. You're leaking heat out of your house. And where it's green, there's very little coming out. And so you've got good insulation, and you're saving money from heating bills or cooling bills in the summer. You can see the studs, the studs are a pretty good conductor of heat. So more heat is coming out through the studs. And greenhouse gases work exactly like that. They're just like insulation on your house. And so the question is, if you double CO2, how much does that increase the insulation of the Earth, cooling to space? And so let me show you. So the answer is the difference is the difference. Now, what I'm showing you here, I hate to give a physics lesson, but what you're seeing is the radiation intensity going out to space. This is a model, but we measure this with satellites, so you can't tell the difference between a satellite measurement and what's modeled here. The radiation going to space is hindered. If there were no greenhouse gases, you would get that smooth blue curve. Let's see. Yeah, you would see that blue smooth curve. That's called the Planck curve, and that was invented by Max Planck. That was the beginning of quantum mechanics. That was around the year 1900. And very soon after, this second German physicist, Karl Schwarzschild, pointed out that because the Earth has got greenhouse gases, it's got water vapor, and it's got carbon dioxide, and instead of expecting Planck's blue curve, you will get radiation that is intensity given by the black curve. So that's called the Schwarzschild curve. And that's the insulation effect of carbon dioxide and water vapor out in these low frequencies. This is water vapor causing insulation. There's the CO2 notch, that's CO2 causing insulation, keeping the Earth a little warmer. Here's ozone at higher altitudes. There's some more water out there. So there's nothing mysterious about this, except that if you start with 0 CO2, you have this green line, which corresponds with black. If you put 400 parts per million of CO2, you eat out a lot of radiation, so you increase the insulation a lot. If you put 400 parts per million of CO2, 0 to 400, you go from green to black. But if you double again, you go from black to red. So this is called saturation. This, I hope everybody understands this, that the point is that the first 400 parts per million of CO2 has a huge effect. The next 400 you can hardly see at all. So that's saturation. So CO2 really isn't very effective at the concentrations we're living in now. It's already done about all it can easily do. So the difference between that black curve and the red curve is that 274 watts per square meter for the red curve, 277 for the black. So it's only 3 watts out of 300 nearly. So it's a 1% effect. Doubling CO2, 100% increased CO2, 1% change in the heat loss, So that's the flux of heat. Now, what will the atmosphere do? If you have a 1% decrease in heat loss, the sun is still shining, so we're not getting rid of 1% of the heat from the sun, and so the Earth will start to warm. But the Earth doesn't have to warm very much to restore balance with the sun. And let me explain why that is. That's, again, very fundamental physics. And, but let me just, before I do that, this is just to show you how well our calculations agree with satellites. So on the left is a calculated spectrum over the Sahara Desert. Here is measured with a satellite. Here's calculation over the Mediterranean Sea. Here's measured from a satellite. Here's the South Pole calculated. Here's measured with a satellite. So what we calculate is exactly what is measured. So you shouldn't think of this curve as a purely theoretical curve. It's something that has been fully validated by measurements. And it's really true that CO2 is extremely puny as a greenhouse gas. So let's see here, this one. It's a little bit of the information going into this. You'd have to include millions of lines of absorption by water vapor, carbon dioxide, ozone, and we've done all of that. And now, how much temperature increase do you need? If you have a 1% decrease in the thermal flux that's keeping the Earth cool, how much temperature rise you have to get? And the answer, again, is very fundamental physics that goes back to these two gentlemen. This is Joseph Stefan, who was a Slovenian physicist working in Austria, and he discovered that the flux of heat goes as the fourth power of the temperature. This was about 1860. And he discovered another very important thing, and that was this student of his. This was Ludwig Boltzmann. And Boltzmann was able to derive this formula from what was known then about physics. So it was not only clearly true from experiment, but there was good theoretical basis for it. But because of that factor of 4, you see the t to the 4th there. Most of you don't live and breathe equations as I do, but do look at that 4. That 4 means that instead of 1% increase in temperature, you only need 1/4%. 1/4% increase in temperature will compensate for a 1% decrease in flux of space. And that's 1/4 of 300 degrees. So the warming is 300 degrees divided by 400. So it's 0.7 degrees centigrade, a tiny increase in temperature. Well, this is a problem for the alarm establishment. You really can't get people excited over 0.71 degrees centigrade. And so what they've done is they've invoked enormous positive feedbacks. They don't tell you that, but that's true. So the numbers that are quoted, if we double CO2, we'll get 3 degrees, 4 degrees, 5 degrees of warming. That's all been multiplied by 3 or 4 or 5, It's not the real number. And so you remember positive feedback. That's built into all of the IPCC models. They disguise it by putting it in these enormous computer programs because you can't figure out what's in the program. But you don't have to know that. It's a little bit like the Gordian knot, I think about your governor. But you can't undo the knot, but you can slice through it with a sword, as Alexander did. So let me say one more fundamental thing, and that is that most feedbacks in nature are negative. They're not positive. And this is so widespread that this even has a name. It's called Le Chatelier's principle. So if you look up Le Chatelier's principle, you'll find that if you look at hundreds of different natural processes in nature, almost all of them, they're negative. They make the effect of the warming, they should make the effect of the warming smaller, not bigger. So if this really is positive feedback, that also violates Le Chatelier's principle. And they're simply not embarrassed by that, because most people have never heard of Le Chatelier's principle. Yeah, but it's true. If you're a good physical chemist or a physicist, you know about this and you scratch your head, how can this be? So I apologize for being pretty technical here, but I think I have a summary slide here. Yeah, that summarizes it. So we're talking about the saturation of the effects of carbon dioxide. And you should think of the carbon dioxide in our atmosphere as like a coat of paint, like the coat of paint on a barn. And it does make the atmosphere colored. And if you could see in the infrared, you would see the atmosphere as a different color because of the CO2. But if you put a good coat of paint on a barn, it doesn't matter if you put a second coat of paint on the barn, like doubling CO2, it won't look any redder because the paint is designed that one coat is enough. If you put on a second coat, you're wasting your money. It won't make it any redder, and that's what we've got with CO2. So if you double CO2, it's like putting on this second coat of red paint. It will have a small effect, but it's very small, and it's really not worth committing economic suicide for. So I will stop here. Thank you.
Thank you very much. All right, committee, do you have any questions for Dr. Happer? I have one. since you've been around government and policy for several years, what would you advise us to do as policymakers to address the direction we're headed?
Well, I think that if you can get more of the public exposed to the craziness of the science, that would help a little bit. I'm not sure that's enough. You know, my own guess is that there's been so much propaganda for so long. You know, most of people, young people, for example, all they've heard since kindergarten is that, you know, we've got a climate crisis and the end of the world's coming. Some of them, you say, well, I'm not sure, maybe I shouldn't have children. You know, it's terrible what we've done to young people. So I don't know how you deprogram people from a cult. It's really sort of a cult. And it may be necessary for some unfortunate country, maybe Germany, maybe the state of California, to do everything that the fanatics want them to do. And then, of course, eventually the whole society will collapse. And then hopefully it will be a small part of the world. The rest of the world will wake up and recognize that this isn't working and we shouldn't do it. Much of the world already knows that. India is over 1 billion people. They're not making a single effort, you know, to really cut back on CO2. They're building coal plants as fast as they can. China's doing the same thing. China's, again, nearly 1 billion people. So what the state of Wyoming does won't make the slightest difference. And it shouldn't worry about it anyway. I mean, China's not worried. They know perfectly well that this is not going to damage the planet. And so we're self-flagellating ourselves in the West, and you know, it's just crazy. You know, there's this old Latin proverb, you know, whom the gods would destroy, they first make mad. And so we're sort of at the mad stage. I hope we're not destroyed. Yeah.
Yeah. Senator Ide, go ahead.
Thank you, Madam Chairman. That was a great presentation. Thank you for that. You guys, have you been in, might be a question for everybody, have you been in debates before on this with a panel on one side and the climate deniers on the other side? And what's their best argument for people buying into this propaganda, so to speak? Thank you.
Well, I think their strongest argument is that, you know, we've got a scientific consensus. You know, if you look around, there are all these climate scientists who agree, you know, that there's a emergency and we have to do something about it. And by the way, make sure that my research grant gets renewed next year so I can help you. And so lots of people, and as politicians too, you know, you vote on things, you know, you don't write some theorem about what you're going to do. And in the end, you have to vote. And so that's a very powerful argument for many people, but it's not the way scientific truth is determined. The scientific truth is determined, but you think of a theory, but then you see, does it agree with what I observe or what I measure? And you know, there's a famous incident in the 30s as the Nazis came to power in Germany. There was a book put out, 100 authors against Einstein, you know, because they, you know, many silly Germans thought of relativity as nonsense. And so they put together this book, you know, they were all professors at German universities. And when this was brought to Einstein's attention, he says, well, why do they need 100? Even one would be enough if they can show one experiment that shows that I'm wrong. And so there are no experiments that confirm any of the predictions of the alarmists. In fact, all of the predictions have been wrong, just one after another. And it doesn't seem to matter. You know, this has failed, that's failed, the third one has failed. The ice was supposed to be gone. You know, Al Gore said the ice would be gone 2013, whenever it was. It's still there. Yeah. So it's you know, I'm real good at differential equations and at, you know, instruments, but I really don't understand people.
All right, I think you're off the hook.
So I think I'm next. Yeah, so-
Yes,
Yes,
go right ahead whenever you're ready.
okay. Okay, sure. So as an introduction, so my name is Byron Soepyan, and I am a research and science associate from the CO2 Coalition. And I will tell you also a little bit more about myself during my presentation
Okay,
and about my experience and background.
all right, wonderful, thank you.
Thank you. Actually, that's not my presentation. Yeah. No.
The top one.
Oh, the top one. Okay. Thank you. So I guess I'll get started then. So the objective of my talk is to basically discuss this one question shown on the slide, which is CO2 capture actually beneficial? And in order to accomplish that, I will first begin my talk by, thank you, by discussing my experience. I did. Oh, thank you. But, so begin, thank you. But I will discuss my talk by discussing my experience with CO2 capture work, because I used to perform CO2 capture research before joining the CO2 Coalition. And afterwards, I will continue by discussing the cost of CO2 capture for the state of Wyoming. And finally, I will close this talk by discussing the dangers of CO2 capture. So in terms of my experience with CO2 capture, I began this work actually at the National Energy Technology Laboratory in Pittsburgh, Pennsylvania in 2017. And I worked on the project called Carbon Capture Simulation for Industry Impact, or CCSI-2 for short. And the goal of CCSI-2 is to develop computational tools to help accelerate the process of scaling up and commercializing CO2 capture technologies. And in this picture, I am on the left, I mean on the right here. And yeah, that was me back in 2017. But afterwards, I discovered this research article right here, co-authored by Dr. William Happer, Gregory Wrightstone, and Dr. Richard Lindzen. And to give credit where due, I discovered this research article, a research report from the website, the news site, LifeSite News. And when I reviewed this report, my skepticism regarding all this talk regarding climate change is confirmed when the report and the authors of the report discuss how there is no climate crisis and that CO2 and fossil fuels are actually beneficial. So I dug in on this topic from further reading from LifeSite News and how they reference other articles from other members of the CO2 Coalition, as well as other researchers who confirm that there is no climate crisis. And furthermore, this research article or research report references the work of Dr. Sherwood Itso. And so I dug in on this as well, and I found research papers co-authored by Dr. Sherwood Itso and Dr. Bruce Kimball, where the co-authors confirmed that CO2 is indeed beneficial and how it increases plant growth and increases food production and increases the drought resistance of plants. So after all this discovery that I made, I left the world of CO2 capture behind and joined the CO2 Coalition as a research and science associate and worked full-time for CO2 Coalition as of July 2023. So, given the benefits of CO2 that I just discussed, and also that Gregory Wrightstone and Dr. William Happer discussed as well, I mean, capturing CO2 does not make any sense. But in addition to that, there's also the fact that CO2 capture is costly as well as dangerous. So let's talk about cost first, shall we? So in terms of cost, it'll cost the state of Wyoming approximately $10 billion to retrofit all 27 coal power plants with CO2 capture systems. For instance, this chart here shows the cost of retrofitting coal power plants with CO2 capture systems, which can amount to $2.2 million per megawatt of net power output. In terms of the energy penalty, the second chart shows that the net power output will be reduced by as much as 26% when these coal power plants are retrofitted with CO2 capture systems. So in other words, Wyoming could spend $10 billion and lose 26% of net power output from these coal power plants. And similar things can also be observed for natural gas combined cycle power plants, where it'll cost the state of Wyoming more than $100 million to retrofit all 3 natural gas combined cycle power plants with CO2 capture systems. And similar as the previous slide, this chart shows the cost of retrofitting natural gas combined cycle power plants with CO2 capture systems, which can be as high as $1.3 million per megawatt of net power output. And the second chart shows the energy penalty associated with this retrofit, where retrofitting natural gas combined cycle power plants with CO2 capture systems can reduce net power output by up to 13%. So in this case, Wyoming could spend over $100 million and have an energy penalty of 13% from the natural gas combined cycle power plants. Now, in terms of the long run, if the state of Wyoming is interested in building brand new coal power plants or brand new natural gas combined cycle power plants, the cost of building these new power plants with CO2 capture systems would increase by more than 60% for coal power plants, and it will almost double the cost of natural gas combined cycle power plants when they are built with CO2 capture systems. Now, in addition to the costs of CO2 capture, there's also dangers associated with CO2 capture. For instance, amine-based solvent method is regarded as the most mature method for CO2 capture. And to summarize how it works, so you have a flue gas from a power plant coming into an absorber where CO2 is absorbed by the liquid solvent. And afterwards, the exhaust gas is released into the atmosphere, which contains less CO2 compared to the flue gas exiting the power plant. Simultaneously, we've got the CO2 lean solvent exiting the absorber and going into a heat exchanger to be heated. And the solvent then goes into a desorber where the CO2 contents of the solvent is removed, and the CO2 is then released from the desorber to be compressed and transported to go into storage. Simultaneously, the liquid solvent exits the desorber and enters the heat exchanger to be cooled, and it is recycled back to the absorber. And one of the issues with this method is that you could have oxidative degradation, where the liquid solvent reacts with the oxygen that are present in the flue gas coming out of the power plant. And when this happens, you could have chemicals forming inside the absorber, which are listed on this slide. And some of these chemicals are volatile, which means that they could potentially be released into the atmosphere along with the rest of the stacked gas, which is ironic given that supporters of CO2 capture system claims that they're actually cleaning the atmosphere with their technology, when actually there's a risk of dirtying the atmosphere with all the chemicals that are formed from oxidative degradation. And in addition to this danger, there's also the danger of underground leakage of the CO2 that's stored underground, where this diagram shows typically what happens to CO2 when it is being pumped underground, where it could be used to help get methane out from underground, or in the enhanced oil recovery, as was mentioned previously. And there's also but then these, again, as I think either Gregory or Wrightstone or Dr. Happer mentioned, right, this doesn't count as sequestration because the CO2 will eventually be coming back up again. But if we want to do real sequestration, then it'll go into a saline formation. And if there's any leak, then some of the CO2 could get mixed with the underground, with groundwater that is stored underground, and could contaminate the those underground water, and potentially contaminate the underground water supply for us. And in addition to this danger, pumping CO2 underground also requires pipelines, transporting the CO2 via pipelines, and corrosion is considered the #1 problem with these pipelines, where the the gases exiting the CO2 capture system could have impurities. And when these impurities are present, they could react to form acids, and the acids can corrode the pipeline. And unfortunately, stainless steel is not considered to be economically feasible for these CO2 pipelines, and therefore carbon steel is used. And in terms of the number of incidents, this chart shows the number of incidents per 1,000 kilometers per year comparison of CO2 pipelines and natural gas pipelines. And what this chart tells us is that CO2 pipelines have significantly more incidents compared to natural gas pipelines, and therefore are more dangerous compared to natural gas pipelines. And there's also the fact that CO2 pipelines carry such a high level of such high concentrations of CO2. For instance, this chart shows a comparison of the CO2 concentrations in various conditions, where the first 5 items shows CO2 concentrations that we are regularly being exposed to. And for instance, in ambient air, the CO2 concentration is only about 423 parts per million. In auditoriums such as this one, it could go as high as 1,600 parts per million, but despite all this exposure, we're still here, aren't we? And in submarines, the CO2 concentration can be as high as 5,000 parts per million, but again, our sailors are doing fine. In fact, there's an experiment that was performed where there are people being exposed 45 minutes to different concentrations of CO2 from 600 to 2,500 to 15,000 parts per million. And the research finds that there's no difference in cognitive ability even when the test subjects are exposed to 15,000 parts per million of CO2. In fact, inside of motorcycle helmets, the CO2 concentration can be as high as 11,000 parts per million when you're not moving and let's say waiting for the traffic light to go from red to green. Now, the danger comes when CO2 concentrations can reach as high as 50,000 or 80,000 parts per million, which I would like to mention is not natural. We don't see these concentrations in nature. And for instance, at 50,000 parts per million, you could have very rapid breathing, confusion, and vision impairment, whereas at 80,000 parts per million, you could go unconscious after being exposed 5 to 10 minutes. CO2 pipelines, on the other hand, have high concentrations of 99.95% CO2 or 999,500 parts per million, which again is not natural. And when people are exposed to such high concentrations of CO2, we learn what happened the hard way in Satartia, Mississippi in the year 2020, when a heavy rain in early 2020 caused a landslide in the area surrounding Satartia. And as a result of the landslide, the CO2 pipeline ruptured only 1 mile away from the center of Satartia village. And during the rupture, because of the high pressure of CO2, the rupture created a crater, and the liquid CO2 formed the white ice shown in this image. And more than 31,000 barrels of CO2 were released during this rupture. And because CO2 is about 1.5 times heavier than air, the CO2 dissipates a lot slower compared to natural gas. And as a result of this incident, 200 people had to be evacuated and 45 people end up being hospitalized. So with everything being said and done now, so what is the bottom line? So in conclusion, CO2 capture is unnecessary, costly, and dangerous, and therefore it is not worth pursuing for the state of Wyoming or for anyone for that matter. And this concludes my talk, and I'd like to thank you all for giving me the opportunity to speak in front of you, and I'll be more than happy to answer any questions you might have.
Thank you very much for your presentation.
Thank you. Thank you.
All right, questions, committee? Any questions? Bob's got one. Bob's chatty.
Okay.
Go ahead.
Thank you, Madam Chair. Right there at the very end, you mentioned, I'll make sure I got it right, unnecessary, costly, and dangerous.
Yes.
Did I get that right?
Correct.
That's a good finish on that presentation right there. That's, politicians are pretty simple, at least I am too, and you kind of like to boil it down to some good verbiage that is useful in conversation. And thank you for being here today and giving us that nice presentation.
Thank you, Mr. Senator.
All right, I don't see any other questions for you. Thank you.
All right. Thank you, Madam Chairman.
Okay, I'm not, my presentation is on a separate drive here. There we go. And if I just. I still don't see my presentation. Oh. What I'm going to talk about today is the effort to reduce CO2 release from electrical energy generation and how it impacts costs and reliability and actually safety of electrical systems. So I want to make a mention of something that Mark Christie, who's a Federal Energy Regulatory Commission commissioner, said in a testimony before the U.S. Senate last May. He said the United States is heading for a reliability crisis. He was talking about the electric grid. And he said the problem generally is not the addition of intermittent sources like wind and solar, but the far too rapid subtraction of dispatchable sources like coal and gas. Now, I agree with him with the coal and gas. I'm not sure that I agree with him with the wind and solar, and you'll see why in a minute. But every utility in the United States is faced with a very rapid shutdown of their dispatchable sources of electrical energy. PJM, which is the biggest transmission operator in the United States, is looking at losing 40 gigawatts of dispatchable generating capacity in the next 6 years because of early retirements of generating units. And I want to mention early retirements because he thinks that wind and solar is unrelated to this. What I'd like to do is just show you some graphs, ask some questions, and tell you what I can determine from looking at the data. And topic number one, should we fully replace thermal power with allegedly cheap wind and solar? And I'm going to make the argument here that thermal sources make a reliable grid without wind and solar, because we've been doing that for a century. Wind and solar cannot exist without thermal sources. So this first graph is a little bit of a mess, and I'm going to untangle it in a second. But if you go to the Energy Information Agency, which is a division of DOE, you can look at the hourly grid monitor for the entirety of essentially the United States. You can look at any balancing area. You can see what's going on with any source of generation. You can see what demand is doing. And you can travel to other balancing areas across the United States if you wanted to. You could follow the impact of storms crossing the United States with this data. Now, this graph contains, this is from Pacific Corp East balancing area, and that covers quite a little bit of Wyoming, all of Utah, and a fair amount of Idaho. And what we've got here is a combination of solar, wind, natural gas plants, and coal. So let's break it apart. And the first thing we'll look at here is, now, before I get here, the goal is to make the sum of all of those generating units equal to the demand. You have to make demand and generation equal to one another on the grid at all times. If they get out of balance, a lot of bad things happen, and if you want to know what they are, I'll answer those questions later. But at any rate, this is natural gas against solar. Solar just pops up in the middle of the day all the time, you see, and it isn't the same height every day. The first day over here, I'm going to try to point right there. You'll notice that solar doesn't just jump up. It jumps up a little bit, and then it kind of ramps clear to the end of the day when it disappears. That was a day that started out cloudy, and it cleared up during the day. The rest of these days, more or less, the solar jumps up and is kind of constant during the day, but it goes up to different heights because of cloudiness and so forth. And you'll notice that every time solar comes up, natural gas production goes down, and when solar goes away, natural gas production goes up. Let's look at coal versus solar. Every time solar comes up, coal production goes down. When solar disappears, coal production goes up. These thermal plants are cycling constantly because renewable energy is coming and going all the time. Look at this particular day, right? Oh, no, don't look at that. Sorry. This day right here. That's a day last fall, and you'll notice that what the coal plants are doing, they're going from about 2,000 megawatts of generating capacity up to almost 5,000. That's an increase of 3,000 megawatts over 3 hours. 3,000 megawatts over 3 hours is the equivalent of about 10 dry fork stations going from just warm idle up to full power in 3 hours. Coal plants were generally not designed to do this. The addition of wind and solar to the grid everywhere in the United States, everywhere where you have thermal assets mixed with wind and solar, you have this endless cycling up and down over large values. And instead of these being early retirements of coal plants, they are early destruction of coal plants because they're worn out. And I know this topic of early retirements of coal plants was at least somewhat important in Wyoming here in the recent past. Let's look at one other thing. This is coal versus wind. And you'll notice that coal balances wind. It isn't quite as easy to see, but there's still a correlation of minus 52%. That's a pretty substantial correlation. And in particular, we say, well, what can we do about this? What if we're going to remove all of the coal and natural gas ultimately, and that's what almost every utility in their integrated resource plan is suggesting, what are we going to do? Well, one thing you could try to do is overbuild wind and solar. But look at right here. This line right here is midnight, so there isn't any solar at all. There's practically no wind. How much overbuild do you need for situations like that? And these aren't at all unusual. You can look at any 8-day period in the course of the year, and you'll have wind that's non-existent at night. What do you do about that? Well, of course, people think there are other ways to handle that. Let's go to topic 2. Do wind and solar actually lower the cost of electric service? You hear this all the time. It is very difficult to substantiate that those two non-dispatchable sources actually lower cost. There isn't a bit of empirical evidence from anywhere on the planet that it's true. But what we can say is, well, there's a good possibility that they have lower marginal cost under sort of strict assumptions, but they both burden the grid because of their presence. And we just saw a second ago that they cause thermal plants to cycle up and down and up and down. That burdens the grid. It leads to non-efficient burning of fuels. It leads to early destruction of thermal plants unless they are built for that kind of operation. The other burden that they cause is that they burden the grid structure. So here is a map. Well, it's a little hard to see, but we can look at a bit of this. These are all of the generating assets of all kinds across the United States as of last January. And all of those earth colors, the big dots, those are individual power plants. And where are they located? The big brown and orange dots are thermal sources, and they're all located in the eastern part of the United States because that's where the population is, and that's where the load is. Thermal plants are flexible as to their location. You can put them right next to the load, and then you don't need a long transmission line to get the power. The hydro assets are mostly in the TVA down in here, but mostly up here along the mighty Columbia and down here at Hoover Dam and places like that. And the solar assets are down here in the desert southwest, and the wind resources are here in the middle part of the country. And for the most part, they're not near where the population is and where the load centers are. And so what relying on wind and solar and hydro are going to do is cause us to build transmission lines all over the place of high capacity, and the ratepayer is going to pay for those because there's no other way to pay for them. What about using only natural gas? Golly, you know, that coal is black stuff and we don't like it, and the natural gas is clear and it must be cleaner than coal. All right, if we start using only natural gas and we get rid of coal, we're going to put ourselves back into something like the energy crisis of the 1960s and 1970s. And there are people in here, I think, that are old enough to remember that. But the origin of that crisis was that we had gotten to the point where we were using petroleum liquids for practically all of our energy in the United States. We were generating electricity with it, and they were used for transportation and so forth. We also had foreign enemies who didn't like our foreign policy. They had become a source of energy, and they were unhappy, and they made an embargo in 1973. We're something like that today. If we get ourselves completely dependent upon natural gas over the next 15 years, we have a foreign entity that doesn't like our policies out here, and that would be the Biden administration. They're doing everything they can to restrict natural gas pipelines and natural gas exploration. So we're going to be dependent upon natural gas, but they're going to fight us every step of the way. What about replacing coal and natural gas with battery or pump storage? You know, this is an extremely difficult problem to analyze because the amount of storage that we need is dependent upon weather. And that is a very difficult problem to get around because it's a stochastic process. It's random. So my guess is that we need a lot more storage than anybody is willing to admit. And if you look at the integrated resource plans of all the utilities, they don't even tell you the storage in correct engineering units. They tell you storage in megawatts and not megawatt hours, which is what really matters. So let's see here. If we take the entire Pacific Northwest, and I've done this is just one of many simulations that I ran, and I took the actual production in 2023 against the actual demand. And in the northwest part of the country, I'm talking about Wyoming to Montana to Washington to Northern California, that sort of a box in the country, and it includes Utah and Colorado. Just to get through barely in 2023, and there actually would have been a couple of instances where we were totally out of power in 2023, we would need 120 hours of average system demand. That would mean about 4.4 billion kilowatt hours of storage. So let me show you what that looks like. This is doing it with, if we do it with pumped hydro, here's what it looks like. It's Hoover Dam and Lake Mead, for crying out loud. Hoover Dam provides 4 billion kilowatt hours of electricity in generating. If we wanted to use that as a pumped storage plant, we'd have to let that equivalent amount of water out through the turbines. And not only that, if we wanted to get back to where we started by the end of the year, we'd have to pump all that water back into Lake Mead. It's a huge job if you try to do it with pumped storage. And the utilities talk about this, but they don't have any idea where they would do this. The opportunities for this kind of storage don't exist any longer. If we do this with batteries, the real problem is, well, not that we don't have the industry to make this many batteries, but the cost would be stunning. Even under the most optimistic scenarios for battery costs, we'd probably be looking at somewhere above $1 trillion, maybe $2 trillion for the amount of storage we'd need just in the northwest part of the United States. And what does that mean? Well, that means, in plain terms, if you look at Rocky Mountain Power here in Wyoming, it's delivering electric service with a capital base, a rate base, if you will, of about $17,000 per customer. If we go to what I think is the bare minimum storage, we'll go over $100,000 per customer. And you know how that gets paid for. It's in your demand charges, your monthly charges, and so forth. They are going to rise substantially in the next 15 years if we're serious. And I'm not serious about doing this, but Rocky Mountain Power seems to be. Topic 5. CCUS is effective. Isn't that a game changer? Well, Byron just talked about that. And it wastes availability of fuels. For a mechanical engineer, that is a mortal sin. You will pay for that in a very hot place that's not a combustion power plant. All right. What it does, though, in general, is that it presents immediate costs. In other words, we got to build a lot of storage, a lot of transmission lines. We got to put up a lot of windmills. We got to put up solar panels all over the place. And we got to do it right now. All of the costs are immediate, and the benefits, if they exist, are way in the future. In fact, if one of the benefits is slowing down the melting of the polar caps, that's 800 years in the future. No sensible person who knows anything about return on investment, interest rate theory, or time value of money knows that what you do is you push your costs away from you as far as you can, and you bring your benefits forward in time. This is just completely opposite of prudent investing. Should we endorse the governor's all of the above policy? You know what? I don't even know what it means. But President Obama had an all of the above policy, and it sounds like the governor's policy. It contains conflicting elements. For example, we can't make a better environment if we are placing renewable so-called energy sources all over the place. Let's just talk about tax revenues for a second. If I read the reports from the Department of Revenue right, Severance taxes from fossil fuels, just I think oil and gas, provide $250 million to Wyoming counties and municipalities every year. If we would try to do that with our $1 per megawatt hour wind tax, we'd need 25,000 3-megawatt wind turbines in the state. And at the present density that they're placed out there, that would be 1/7 of Wyoming covered with wind turbines. You can imagine what that does to our environment. It ruins landscapes, viewscapes, and let's not even talk about migratory birds and other protected species that are protected by the Migratory Bird Treaty Act of 1916. That treaty is over 100 years old. Or the Bald and Golden Eagle Protection Act, which was actually dates from 1940. These are really old acts where we were trying to protect species, and we just seem to be unaware of the dangers here. I don't know if any of you know this, but there's a guy in Laramie by the name of Mike Lockhart who tags eagles and tracks them. And there are migratory golden eagles that start the year up in central Canada, and they migrate during the winter clear to central Mexico, and they go right through the Shirley Basin to get there. All right, topic 7. Shouldn't we do all we can to reduce CO2 emissions anyway? I'm going to tell you, ignore everything these gentlemen have told you. CO2 is a danger. We got to do something about it. Well, look, China is going to be producing by 2030 20 billion tons a year. India will probably be close to the same. We here in Wyoming do not have our hands on the control knob. In fact, nobody in the Western Hemisphere does. It's the other 7 billion souls on the planet who do. If we do all of this expense, Rocky Mountain Power figures that we will reduce our emissions by 50 million tons per year, which sounds like a lot. But in comparison to China and India, I'll combine the two of them, if they produce 40 billion tons a year, they will replace what we have saved every 10 hours. Every 10 hours. I saw somebody claim that they were bragging about the fact that something that they were doing would reduce CO2 by 68,000 tons a year. That's 1,800 milliseconds of what China does. 1,800 milliseconds. That's, you know, I'm getting to be an older guy and I'm kind of slow. That's my reaction time. 1.8 seconds is what we're talking about. No. And you know what? I have gone to an awful lot of hearings, and there's a lot of governing boards and regulators who obsess over the aspiration to reduce CO2. And if you get distracted from your core competency, you can guarantee bad outcomes. We have 2 county commissioners over in Albany County who voted for a rather large wind farm because they said, we got to do something about climate change. And nobody in Albany County is going to do anything about climate change. Stick with what your competence is. I think I'll quit there. Thank you.
Thank you, Mr. Kilty. Are there any questions? Senator French.
Thank you, Madam Chairman. Sir, do you have any idea how many, if they do away with the fossil fuels, coal, natural gas, oil, whatever, how many wind turbines and solar farms would have to be put up in the United States to cover the electrical demand?
I've looked at this problem a little bit. I'll do it in another way. Wyoming, as you know, is a major exporter of energy. We produce, what, about 11% or maybe 12% of the nation's energy? If we want to shut down all of our fossil fuel mines and plants and, you know, get to the point where we don't account for any CO2 at all and just go to wind turbines, we'll talk about that, we would have to occupy an area way bigger than Wyoming. Wyoming can't possibly do it. I think to power the entire United States would probably take about 10 Wyomings. In other words, we're going to run out of Wyomings before we can get that job done. And Wyoming is not going to get solar panels. Pacific Corp was real clear about that in a number of public hearings I went to. Wyoming's going to get wind turbines. The solar panels are going to go down to Utah because that's where the resource is. And I don't relish a power system where we've got the butt end of the thing. We got wind turbines all over the place with no backup. Remember, they want to get rid of all of our thermal generation, and we will depend upon sometimes some solar energy coming up from South Utah, but storage that doesn't exist anywhere in the system. And they keep talking about it, but they don't even tell you the right units. You know, I just retired as an engineering professor. If students gave me a calculation with wrong units in it, they would get a talking to. But I can't do that to Rocky Mountain Power. They won't listen to me. So it gives you an idea of the scale of the problem. People fundamentally do not understand the scale of this problem.
Thank you. Senator Ide.
Thank you, Madam Chair. I'll be real quick. You hit on my question right there toward the end on the, the governor's slogan and other proponents of all of the above. I always have problems with that. And I guess my question would be, is there such a thing as a commercial economic, you sound like an economic sort of a guy, commercially economical wind or solar without subsidies or, taxpayer incentives to make it happen?
You know what would be interesting to just run an experiment, take away the subsidies for a while and see what happens. But as you know, on the East Coast right now, the East Coast, you go further east in the United States and the capacity factor for wind drops substantially. And wind turbines aren't really worth very much by the time you get into the Midwest or you get into Pennsylvania and so forth, unless you locate them just perfectly on ridge tops and so forth. They've been talking about putting them out in the ocean. And even with bids with subsidies as rich as 10 to 12 cents per kilowatt hour, and that's what we pay with everything else added in, our demand charges and the taxes and fees and everything else. That's expensive power right there. 4 of those big wind energy companies have pulled out of their commitments because they said we can't make money at these prices. Wind is, yes, it's got maybe zero marginal cost, but gosh, it's an awful lot of upfront costs to get there.
Senator French.
Thank you, Madam Chairman. I'd just like to say thank you to all 4 of you that you have given us your honest, scientific opinion through your research lifetime. You seem like a younger fella. Lifetime of research and stuff. I appreciate the honesty. I truly do. Thank you.
Thank you.
Senator Cole.
Yeah, thank you, Chairman. I've always been curious about this question. I don't know if you came prepared with an answer that I want to ask about of her question, but it's real simple. I will just take wind turbines. Total cradle to grave cost, production, people going to said areas to produce said wind turbines, material cost, how much energy went into that material. Total cradle to grave, all the way to when you have to destroy it because it's out of time, it's past its service life, as opposed to a realistic energy output over the said same lifetime of that equipment, and compare those 2 numbers, because I don't think it pays myself, just as a practical person. But I'd like to see numbers that said this is what it costs to produce, and I don't mean like I don't know what I'd call it a value-added energy production, because it costs so much money or cost-added energy production to make that thing, right? It's kind of like the cars. Batteries don't come free, but we got to just take turbines, just take the total input cost, and that's the people, the workers, everything that goes into that thing. And because I'm tired of people cheating on being mentally dishonest, economically dishonest about what this really means, because I think that might help mount a defense for why are we doing this? Forget the government subsidies for the moment. Just what do they put out? Because there's parasitic costs while they run. They consume power. Of course, I've never seen anyone honestly put up a total megawatt output. I always thought that would be interesting to see if they would put a billboard up that said this facility this wind farm is putting out X amount of power, and then have it actually be a running total back and forth between parasitic loads and output. And when it's not, wind's not blowing, of course, you wouldn't have much of an output. You'd have a cost, because it costs money to have those things idle, power-wise. But just some sort of honest evaluation. You folks seem to be the right people probably to do this. And I will add, I do really, I didn't know where the artificial star came from in astronomy, but it's interesting to know somebody close by came up with that idea. And not that I can afford my observatory to have such an artificial star in it, but I do understand it. So I just that question, as a really a general question, could we, and that would go with solar, it'd go with pretty well all these, but I thought wind is pretty well low-hanging fruit. Any thoughts on that?
You can call it a low-hanging fruit, but look at the components that go into it. We've got you've got to go all the way back to mining to get the iron, the copper. We have to go back, amazingly, to petroleum production to get the plastics. We've got to go to concrete to get the foundations. We've got transportation costs in all of those things. We've got labor costs all over the place. We have got taxes everywhere that, as you know, companies don't pay taxes, customers do, right? I went down this path one time trying to figure out how much CO2 is embodied in building and transporting and placing those things, and I gave up because it's very difficult to find all of those numbers, and there's a lot of different numbers to find, and they don't always apply because things are built in different places, as you know. Not long ago, an outfit called CFACT, which is the Committee for a Constructive Tomorrow, they are guys really fighting wind turbines on the East Coast, largely because of Wales. They gave a teaser title to one of their papers that said, here are the energy costs involved in wind turbines. And the stinkers didn't actually give us the cost in the end, because I think it's a really difficult problem to get at. But as you know, it's not insignificant. It takes a lot of energy to put these together.
If I could weigh in, I think we may get some help from Europe, because if you look at Germany, and especially Germany, where they've gone headlong into, wind power, industry is leaving Germany, and people are losing their jobs, and farmers are blocking the Autobahn, and not only Germany, but also in France and in Holland. So fingers crossed, every time they do another crazy thing in the European Parliament, I always clap. I say, the sooner the better that they bring this crisis, to the front, where finally they'll have to stop. So you should all encourage the European Greens to do more, because that will help us eventually to not do the same thing.
All right. Did you have a follow-up, Senator?
Well, no, I guess I did. Thank you, Chairman. As you mentioned, you don't have to be very bright to be a politician, just popular. So you folks, I consider capable. And I think it is going to take some work to come up with this number. And I'm obviously, it's not going to be exact, but something more than we have now is going to be greatly appreciated. That's what I'll just leave it as. But so thank you for listening.
Take it under advisement.
Well, thank you all for your presentations. We appreciate you coming so much, and hope we can continue a relationship with you as we try to craft policy and educate folks on the issues facing our state and our nation regarding energy policy and CO2. In closing, does anyone have any thoughts, and you can reach out to us later if you do, policy-wise, that can help us? And maybe Kevin, you do as well, but just a broad overarching thought that we should keep in mind as we traverse this legislative session and the things that are facing us here in Wyoming.
top of our head right now.
No? Okay, all right. Well, with that, thank you guys so much. I did want to point out, just for everyone here, that we have public comment on some sheets, line sheets, if you want to leave your name and provide any public comment that you would like the committee to see. Kim had those sheets, and Lily over there. Kim, could you give us the email address that will be, we have an email address that will be active during session where you can provide public comment, because we will not be taking comment from the public here at this meeting, but you can provide it that way. I also wanted to show you the resources that the CO2 Coalition has provided for us. I'm sure you can get reports at their website or from them in some way. Greg's book, A Very Convenient Warming, Wyoming Climate Change, CO2 Should Be Celebrated, Not Captured, and there are copies here tonight. But for those of you watching online, I think this report is available on the website now. Fossil fuels, the greenest energy sources, and challenging net zero with science. And so those are all great resources for everyone who might be interested. With that, committee, do you have anything else? Any other questions or comments about our hearing today? Senator Ide.
Madam Chair, thank you. Quick question. I listened to another presentation from Alex Epstein that wrote that book, Fossil Future, or yeah. Is the word fossil fuels a misnomer?
Kind of, sort of. It's most of the fossil fuels, the oil and natural gas are, well, obviously coal is fossilized. It's wood for the most part. But most of the oil and gas are, I know a lot about this, is sourced from actually algal blooms that bloom and die, fall to the bottom, bloom and die. And it accumulates year after year, millennia after millennia, after millions of years, and it accumulates into these thick, organic rich beds. So if you consider algae a fossil, I think it was misnamed. But yes, and there's been a lot of incorrect talk about abiogenic oil, which is just completely false. It ain't happening. It's not happening. And so this is really organic material that's accumulated, and the name fossil fuels is, I think, a misnomer.
All right. Well, thank you so much for educating us tonight. I know I've learned a lot, and it will help me as we craft policy for the state of Wyoming. Thank you so much, and this meeting is adjourned. Oh, Kim, did you have one more? Oh, we need to tell you the email address in case you want a public comment. One more.
The correct email address is senate.agriculture@wyoleg.gov.
Thank you for that reminder, Kim, and thank you everyone who came tonight.